So let's talk a little bit about materialized views with Snowflake and the difference from materialized view and regular view, and when should we use materialized views. So one of the things that we need to look at is how often is the data changing? When we're talking about a materialized view, it's important to understand the difference between a materialized view in Snowflake and a regular view. And there's some great use cases for materialized views, but materialized view actually has its own storage. And so what happens is, like in this case, we have table A, and we create a materialized view, view A1 off of table A. What happens is this view is almost like a table. It's got its own storage, and it's organized in its own way. And so there's a cost of having a materialized view. If we've got a table that's got a high churn, if we create a materialized view off of that table, what's going to happen is we're paying for that, because every time the data changes in table A, every time new data comes into table A, it's also got to process that into that materialized view A1. And so there's some cost there to consider. So we want to understand how often is the data changing, so that we want to make sure that we're getting the bang for our buck, right? So that's an important thing to understand. If you look at our three materialized views down here, you'll see that there's a couple of things that we've got. So view A1 allows us to have multiple clustering options. So what are we talking about? In Snowflake, again, we know Snowflake doesn't have indexes. It doesn't. It's organized all of its data into micropartitions, and some of the secret sauce that's there is that we can organize those tables. We can organize the data in those micropartitions and basically cluster that. And what that means is we can, let's say we've got a table, maybe we've got like an orders table, and we query that table. One of the ways that we query that table is by date range. We're going in there, it's a very, very large table, and we're usually going and saying, hey, I want to see all of the orders from last week, or I want to see all of the orders from last month. We're querying that by time, by that date. And so what we would want to do is we would want to have that table organized so that all of the dates, all of the orders of a specific date are in the same micropartition, or in very few micropartitions. Because what happens in Snowflake is if we go to query that order table, and all of the orders for one date are spread over many, many micropartitions, that query is going to have to go get all of those micropartitions from the storage layer. It's going to cause us to have less performance. And so where this really comes into play is, let's say we've got other use cases for that order data where we need to go in and we need to query that by product type. We don't really care what the date range is. We just want to know orders for specific product types. And maybe there's another one where we want to see orders by certain geographic areas, or by customer types. And so there may be a couple of different use cases of how we want to consume that the data from that table. What we can do is we could create multiple materialized views, and we can put a cluster key on each of those views. And so we could have one materialized view of the table, the orders table, that's organized by date. We can have another one that's organized by product, and we can have another one that's organized by geography. And then when we go in to query that table, we don't even have to know which of those three views are. We can run a query against table A and say, give me all of the orders for last week. Table A Snowflake is the optimizer, smart enough to say, hey, wait, we've got a materialized view over here that's organized by date. So we're going to use that when we go after this. If we run another query by product, it's going to know how to go after that materialized view. So multiple clustering options, great use case for materialized views. Also long-running aggregates. If we need to, we've got a huge table that's got very detailed, granular level of information, and we want to be able to. We need to be doing some aggregates on that, and so we can do sales by month or those types of things. That's a great use case for materialized views also. And semi-structured data. We can load, semi-structured data into Snowflake, into a table. We could use a materialized view to flatten that out to allow us to analyze that semi-structured data. So some of the things that we want to look at that can help us with our data pipelines, and make it so we don't have to have 3 separate order tables that we load 3 different ways in our pipeline. We have one order table and then materialized views that can allow us to manage that, to manage the way that the micro partitions are organized, to manage the aggregation levels, number of different things that help us there.
Yeah, so materialized views in Snowflake specifically have superpowers. It's, if you're a DBA and you're coming from Oracle or from perhaps some other environment where materialized views were a way for essentially physicalizing the table, materializing the table. In Snowflake, it goes beyond that. It not only gives you that ability, but it gives you some of these superpowers in terms of getting better performance. You can have one materialized view clustered one way and another materialized view clustered another way, so that if you have queries coming in that need to support different kinds of use cases, again, no indexing, but because of the way this data is distributed in these micropartitions, in these blobs living in blob storage, you can optimize and change dramatically the performance of the queries based on doing a little bit of data engineering work.
Yeah, and one other thing on the materialized views real quick, just a caveat, and you have to make sure that I remind folks of this all the time. There is a limitation of materialized views. The materialized view is a view on one and only one table. So we can't have a picture here where we've got table A and B, and then we've got materialized view AB1, which is joining those 2 tables. A materialized view is can only work on one table. It doesn't have to have all the columns of the table. So if we've got a table that's 100 columns wide and we need 4 of those in a materialized view, then we can do that, but we just can't have multiple tables in a materialized view.
Hey folks, thanks for checking out this cut from our broadcast. To see the full show, click on the link in the video description. Also, check out our Learning Center, which has white papers, events, live streams, and short explainer videos on a wide range of data management topics. And of course, if you like our content, please share it on LinkedIn. That really means a lot to us. Thanks again for checking us out, and we hope to see you in our next broadcast.